How would you like to watch a pilot land an aircraft that has not yet been built, but the equipment of which this is a part accurately simulates its behavior?
Having achieved important successes with aircraft simulation, Ames Research Center decided to investigate areas where simulations had not produced results comparable with flight. A committee was formed in the summer of 1971 to conduct that investigation and to make recommendations for facility expansion.
June 1971, Len Roberts forms a committee to investigate and recommend extension of Ames flight simulation facilities. Dr. Roberts was director of aeronautics at the time. The committee was Maury White, who was chief of the research branch that was doing most of the simulation. They brought the user needs to the committee. Fred Drinkwater represented the pilots, was valuable in telling us what the pilots wanted. I'm John Dusterberry, and I was assistant chief of the Simulation Science Division, and I was to represent the operator's point of view, make sure we had something that would operate. And Dave Engelbert, who was from the facilities design group and eventually became project manager of the construction of facilities, and he was there to make sure the rest of us didn't require something that he couldn't build. August 1971, the White Committee recommends construction of a new simulator with motion system having plus or minus 30 feet of vertical travel. The other translational and rotational excursions were also recommended, as well as the velocities and accelerations.
The committee determined that the aircraft landing, including flare and touchdown, was the most difficult maneuver to simulate correctly with the existing equipment.
So our thoughts went mainly to how could we do that better. I'm sure we were heavily influenced by a report done by a British organization, Blind Landing Experimental Unit, and they discovered that the pilot could land the real airplane better than he could land the simulated airplane.
These results led researchers to speculate that the reason was the lack of good vertical acceleration cues. To provide these acceleration cues on a sustained or low-frequency basis would require large travel in the vertical direction.
So what we finally came up with, that we required plus or minus 30 feet of vertical travel, and felt that would meet the acceleration cues required.
The committee reported the requirements of a new motion system to include rotational performances similar to those of the flight simulator for advanced aircraft. Based on experience with that simulator, lateral cockpit motion was recommended as plus or minus 20 feet.
Lateral translation was determined mainly from Bray's experience on the flight simulator for advanced aircraft, and he decided that plus or minus 20 feet was plenty in the lateral travel.
A modest amount of fore and aft excursion was specified, but it was recommended that the cockpit be capable of being rotated 90 degrees so that lateral and fore and aft performances could be interchanged. However, the precedent-breaking requirement was for a large vertical excursion. Experiments conducted on the height-controlled test apparatus, which had 100 feet of vertical travel, determined that plus or minus 30 feet were needed in the vertical axis.
And a report of this nature was put out by the committee about August of 1971. January 10th of 72, the Ames Ad Hoc Simulator Facilities Panel described and recommends VMS. And a preliminary engineering report had been submitted to headquarters. Ames delegation, headed by Lauren Bright, visited NASA headquarters and Air Force Flight Dynamics Lab to reveal plans for the VMS. During 1972, there was I guess you would call it missionary work to let headquarters know what Ames was doing about VMS design, to let other government agencies who were interested in that sort of facility, let them know what our plans were so that hopefully to have them support our plans or perhaps alter our plans to make the best fit with them and their needs. And during this time, preliminary plans and preliminary designs were going on. January 1973, construction of facilities request was submitted to the headquarters facility group, and this is comprised of taking an existing simulator with a small motion system on it, including both its cab and the motion system, and installing it on a plus or minus 30 feet vertical motion system. This was similar, but in ways quite different from what was eventually submitted for as a construction facilities request. February 1973, Bray's Technical Memorandum X62-36 was published, quantifying and verifying his insight into vertical motion requirements for good simulation aircraft landing. And what the work was done was to verify the insight that was used to specify the large vertical travel. There was the opportunity to take the height control test apparatus, which was on the end of the 40 by 80 wind tunnel and had 100 feet of vertical travel, and to connect that remotely to a out-the-window scene generator and do some actual landing experiments with and without motion, and verify that motion in the vertical plane was a decided help in the simulation. Dick Bray did this work in the summer and fall of 1972 and was able to show such a tie between vertical acceleration and satisfactory simulation of landing. The report, however, was not published until February of 73. February of 1973, Engelbert and Dusterberry prepared multiple choices of the use of different existing equipments. In the early part of 1973, we were concerned about getting the C of F proposal approved and looked at all kinds of variations using existing equipment on a plus or minus 30-foot vertical motion system to see if we could cut the price without seriously affecting the cues we felt were essential.
Design studies continued through 1973, and bids were solicited for construction of the vertical motion simulator in 1974. Construction of the VMS was approved in the 1975 budget.
And in the spring of 1975, construction of the vertical motion simulator actually started. And that's about it. That remark was to the camera, not to you.